pi, and it's up at 1, it does go down to -1, but it goes like this, it goes do, 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 and then it keeps going down, right? And it goes this way here. And then it goes down, and it just keeps doing this, right? And then clearly, you're gonna see it fails the horizontal line test. So you're thinking, well, great, where would I restrict my domain here? What you do, what they choose, and we'll talk about why, what they do is they restrict it to be from 0 to, what is this? This is actually pi, right? This is pi, right? Yeah, okay, I had it at the wrong spot. I was like, that's not right. They're restricted from 0 to pi. So would you agree that the cosine curve from x equals 0 to x equals pi, well, it passes the horizontal line test. So again, if you're asked to give answers and you're dealing with arc cosine, just make sure those answers lie between 0 and pi. Okay, this is a great technique if you know the graphs of all 6 trig functions. I've got a master's degree in math. I don't know what the cosecant looks like or the secant. I could care less what they look like. I know they look like you used the right. Yeah, I could actually come up with it. I could. It's not that hard of a graph, but I don't want to do that. So is there another way that we can get these answers, right? Here we can see it's from -pi/2. So when you're dealing with it, it's what, -pi/2 to +pi/2. And what is it for cosine? 0 to pi. Okay, so is there another way? Yes, there is. Let me show you a way that I came up with on my own, just on my own. And it happens to match what the book does very well, and you can do it without having to know the graphs. See, because now you got to know the graphs of tangent, which is easy. Tangent graph is easy. But the cotangent, that's not as easy as most people think, or the cosecant or the secant. You don't have to do that. Here's what you do. It's about having a positive and negative representation of each one of the trig functions. And here's what I mean by that. Well, let's look at sine. Now, it always starts in quadrant 1. Is the sign here positive or negative? Positive. Is the sign positive or negative in the second quadrant?
Yeah.
Positive again, right? So you don't want to go quadrants 1 and 2 because you don't have both. You do not have both a positive and negative representation of the sign in the first and second quadrants. So you start with quadrant 1. How about first and fourth? And what is the sign of the first quadrant? Positive. What's the sign of the second quadrant?
Negative.
Negative. So would you agree we have a positive and negative representation in the first and fourth quadrants? Okay. Now what is the fourth quadrant? Would you agree that down there is what? Negative pi/2? You could say 3 pi/2, but negative pi/2 to what? There it is. Negative pi/2 to positive pi/2. Works every time. Let's look at cosine. What 2 quadrants would we need to use for cosine if we need a positive and negative representation? Would we go 1 and 4 again?
No.
No, they're both positive, right? 1 and 4. So what would you want? 1 and what?
1 and 3.
Yeah, you want to do one that's right next to it. You don't skip over 3. It's got to be right connected to it. 1 and 4 or 1 and 2. 1 and 2, correct? Oh, okay. 1 and 2. That goes from what? From what to what?
0 to
0 to pi. Well, let's see. OMG. Oh my gosh. Can't believe it. Okay, let's take a look at tangent. Now, I'll do it 2 ways for you. Right, sound effects are optional. Here is a very rough sketch of a blue tangent curve. Okay? Now you can see that from negative pi/2 to positive pi/2, does it pass or fail the horizontal line test? Pass. So we know that for the arc tangent, y equals the arc tangent of x, we are dealing with this interval. I'm going to make it open this time to talk about why. Why do I have to make it open? Take a look at the graph. What happens at pi/2, negative or positive? They're asymptotes, right? Careful saying that word. But yes, they're asymptotes. They're asymptotes. Oh, you're videotaping me. I just said a bad word. Okay, so it's, I can't really is recording this lesson for students who are out, which is really cool. So, awesome. So, asymptotes. And so there we go, asymptotes. And so yes, it cannot be equal to negative pi/2 or positive pi/2, right? Okay, very cool. Let's see if this trick would have worked. Would I have gotten the same interval if I'd used this idea of quadrants? We need a positive and negative representation. Now, let's first try quadrants 1 and 2. That's not going to be the answer, but let me show you why. Do we have a positive representation of the tangent in quadrant 1? Ding, 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 ding. Do we have a positive representation of the tangent in quadrant 2? Yeah, we do. Yeah, positive. Yeah, this is positive, right? Because sine and cosine are positive. What's the sine and cosine over here? Sine's what? Positive, what's a cosine? Negative, so I have a positive representation of tangent, negative representation of tangent. So why don't I use 1 and 2? Because take a look, positive here, right? What's down here? Negative. So why would I choose these two quadrants over these two quadrants? There's a reason why. Okay, between here, between 0 and pi, what is there? Pi over 2. And what do we know about pi over 2? Is tangent even defined there? No, so we couldn't say negative, we couldn't say this, 0 comma pi, because that's just not true, right? It's just not true. At pi over 2, which is between 0 and pi, it's undefined. So we'd have to create like 0 to pi over 2, but not pi over 2, and then pi over 2 to pi. So there's an easy way to do this if we include quadrants what? 1 and 4, that is correct. You want to look at quadrants 1 and 4. Your only question is when you're dealing with arc tangent, when you, right? 1 and 4, what is the angle down here? Negative pi over 2. And what is the angle up here? Okay, good. Now, can it equal negative pi over 2, or can it equal pi over 2? No, the tangent's undefined at those 2 points. But notice how this is a lot cleaner with open brackets using quadrants 1 and 4 than if we had used quadrants 1 and 2. But here's how you, if you insisted on using quadrants 1 and 2, because you do have a positive and a negative there, you'd have to say this. Negative infinity, no. Negative pi over 2, up to 0, or 0 comma pi over 2. This is what you'd have to do if you insisted on using 1 and 2. And so if you could, that would be your representation. And would you agree that this is honestly saying the same thing as this? Well, of this one that we're seeing up here. Right? So we're good. So we don't want to overdo it like that here. So basically, I think it's easier to look at the quadrants and find a positive and negative representation. The cosecant's the same way. Or the secant. What is the secant? 1 over cosine? Yeah. So it's going to be the same thing as cosine, because you need a positive and negative representation of cosine. That means you need a positive and negative representation. You get your positive and negative for secant. So you just have to remember those